Viewers like you make this program possible. Support your local PBS station.
This is the story of energy, humanity's single most important resource. Energy is the force that built our modern world, but it's often invisible to us, hidden in plain sight. Before modern energy, people had to walk miles to get water, carrying it by hand or on their head. With a modern energy system, we can move water with an electric pump, freeing up precious time. Once water is plentiful, we can grow abundant food. And with abundant food, there's extra time for education. Educated people have access to economic prosperity. Some can even operate a business and accumulate wealth. With money, more people move to cities where there's more to do. Cities need transportation to bring goods back and forth. And people are more likely to travel to see the world. All of these luxuries give us a quality of life worth protecting and even fighting wars over. As a society, we're making decisions about energy that will impact our planet for centuries. So we must understand it. And we can understand energy by looking at cities. Are cities the most energy-efficient places to live? Or are cities the ultimate expression of endless consumption, excessive pollution, and waste? Is urban living less damaging to the environment? Or does urban life suck up the energy resources of the planet? Is urban density safer because of the access to modern health care? Or does urban living hasten the spread of pandemic disease? Do highly advanced technological cities foster a sense of community? Or do they dehumanize and isolate us from one another? This is Power Trip, the story of energy. Every day that we walk the streets of an urban environment, we might not notice it, but there is a hidden force that allows a city to function. Hidden in plain sight, right before our eyes. Energy. Modern energy is virtually embedded in each piece of our urban landscape. From the steel for the buildings, pavement for the streets, to clean tap water, interior climate control, transportation, elevators, food, culture, medical care, security, technology. Energy was needed to create these things, transport them, build them, and keep them going. Energy is the lifeblood of urban existence. The world's population has doubled in the past 50 years, from 3.5 billion to over 7 billion people. As the population increases, more people are abandoning rural areas for modern cities. This trend has continued for almost a century. Without modern energy forms, the concept of a modern city would be impossible to fathom. But how did cities begin?
Modern-day Mesopotamia is the countries that are now Iraq, parts of Iran, Syria, southern Turkey, and that is the place that's often called the cradle of civilization. Before the beginning of cities, there was a period of intensifying agriculture when people first began to cultivate plants and animals instead of just relying on what they could get from hunting and gathering in the countryside.
Cities started to form as we achieved stability in food production. As we had more food produced, you could have more people do other things other than grow food. And so you had trading societies or other specialties that could be supported by the other people growing food.
The first cities are about 6,000 years ago. They had many, many different civilizations that built urban centers with great queens and kings, very sophisticated metallurgy, lots of trade and exchange, for example.
Cities make sense if not everyone needs to farm, and you might have other things that are going on. You might have cultural activities, you might have trading, you might have manufacturing. So cities achieve that. They also allow for these more complex societies.
The beginnings of modern energy could probably go back to the Roman world. One of the interesting things about this ancient Near East or Mesopotamia is that it's actually a very difficult environment. For a long time, it was called the Fertile Crescent, but it's actually a very difficult place. It's hot in the summer, it often has drought and other kinds of environmental difficulties, and more recently, one of my colleagues has called it the Fragile Crescent. From the very beginning of urbanism, water and energy have gone together because there was the creation of canals to be able to bring goods into cities. Water and the management of water is something that has always been at the heart of ancient cities. Water and energy go together because it's with those canals that the essential fuel could come into ancient cities. The idea of using fuel was something that was very important for urban economics.
Cities are responsible for a lot of energy consumption. We've been heating our buildings or shelters or caves for thousands of years. Burning of fuel gives you heat that you can use to warm up the area you are.
That's not only for cooking food, but also for industrial processes. If we take the example of pottery, in order to manufacture pottery, you had to have all of those component parts. So clay is coming in, you have fuel coming in, and then you also have water. Cities were a way to help solve problems and to pool risk-taking in challenging environments.
The first settlements were founded as transfer points, where there was a change from one form of transport to another. From the beginning, tools were needed, as well as medicine, clothing, weapons, goods they could get only by trade.
A city can pull together resources that are otherwise very difficult for somebody in a village to get, because there's always going to be somebody who is going to have the initiative to transport goods and services into that urban environment.
Trade, as always, was dependent on transportation, by land and by water. So towns sprouted around busy harbors.
Cities were such a popular concept that they were started independently in a whole variety of different places. And each of those places has its own very robust networks of urbanism, so that by the time you have electricity, all of those things had a huge impact on what people could do in cities.
Villages became towns. Towns became cities. And manufacturing was transferred from quiet homesteads to factories. This transformation we call the Industrial Revolution.
It's no surprise that the rise of major cities coincided with the Industrial Revolution, which coincided with the rise in newer, energy-dense fuels such as coal and petroleum. The story of modern cities and modern energy go hand in hand. As our cities evolved, our energy systems have evolved alongside them. Do energy improvements enable new cities? Or do new cities enable new forms of energy?
Just as you had the rise of London, a great city in England after industrialization, you also had the rise of great cities in the United States. Chicago comes to mind. It's sort of the place where natural resources, factories, and modernity all came together.
Less than 140 years ago, such a view would have disclosed only a log fort and a few cabins at the mouth of a muddy river. When gold seekers were rushing to California, Chicago boasted a few business blocks and streets of bottomless mud. Now, with nearly 3.5 million residents, the city has become the second largest center of population in the Western Hemisphere. Such growth reflects Chicago's location, midway between the agricultural West and the industrial East. It is the consequence of great industrial enterprises, great mercantile institutions, and the great markets for grain and livestock, which are all the inevitable consequences of Chicago's geographical location.
This is the city of Chicago. Look here, the city goes out into the flatter areas, the plains and the prairies. That's where you get a lot of the raw materials, the
the wheat or the corn or the pigs that would come into the city for processing. And if you go even further out, you eventually get to the foothills and the Front Range and the mountains, the Rocky Mountains. The Chicagoan Empire, the reach of Chicago, was as big as the Roman Empire at one point in terms of its influence with mail order goods from Montgomery Ward and Sears and Roebuck Company, as well as all the industrial might it had.
A professor named Bill Cronin called Chicago nature's metropolis because there was a symbiotic relationship between Chicago itself and a vast swath of nature that surrounded it.
Chicago had this great location in the middle of prairies, and then we had the Chicago River that takes you through the Mississippi, also the Illinois-Michigan Canal, as well as the Great Lakes. And so we were able to really take these commodities and push them out across the country through rail and through boat. Really was this great transportation network, which Chicago still has. We still are the center of the rail system in this country.
Chicago was growing so quickly, it didn't have a lot of time to think about a logical, strategic plan to guide growth.
Physically, a handful of our cities were planned from the start, like Washington's famed wheel and spoke design and the gridiron pattern, a popular 19th century city plan. But due to the incredibly rapid expansion, most cities outdistanced their planners when there were any, and grew into a maze of complexity and confusion.
There were many problems in the first wave of urbanization in Chicago, particularly, I think, pollution with the industry, with the stockyards, with the steel mills. It was not a healthy place.
Many of the things that we take for granted now, like clean streets and sewer systems and clean drinking water, are all things that are part of the infrastructural development of urban centers.
Most people in cities lived at very, very high density. High density meant that they didn't have much room and they were overcrowded and they were exposed to disease and life was short.
The city stank. You know, we were the hog butcher to the world, so we had stockyards full of hogs. We also had carcasses. That was not very pleasant. The smell of the pigs were not very pleasant.
There's stories that if you worked in the stockyards and lived near the stockyards, when you actually went out in the country, the fresh air made you ill.
You know, when we look at the statistics of death and disease, even in the 19th century, it's shocking.
And then you had all these major railroads going down the front yard of Chicago, and it was smelly and it was sooty. And then you had Sears. It was a great merchandise and catalog center, and it was so large that they took 17 rail cars of coal every day in order to supply it with the energy needed to run. So it was just amazing to have all of this going on in the city.
People moved to lower density locations to live a better quality of life.
Smoke makes prosperity, they tell you here, no matter if you choke on it. We got to face life in these shacks and alleys. We got to let our children take their chances here with rickets, typhoid, TB, or worse. They have no business here, this no man's land. This slag heap wasn't meant for them. There's poison in the air we breathe. There's poison in the river. The fog and smoke below ride up and choke us. Smoke makes prosperity, they say. Does this mean that there's no way out for us? There must be something better. Why can't we have it? A decent home.
A little more fresh air, better air quality, less horse manure in the streets. So the energy was important, but the escape from very squalid inner city conditions was also a motivating factor.
I like to say that Chicago burned down at the right time. It was a hot, dry summer, October 8, 1871. We hadn't had rain for at least 3 weeks.
In one terrifying day, thousands of homes and public buildings were destroyed.
The fire was a result of the rapid building, the balloon framing, the wood, lightweight construction of so much of the city that turned out to be not sustainable.
It was 2.5 miles. 100,000 buildings were demolished. Most of the city at that time After the Chicago fire, there were 100,000 people that were left homeless. So the city had to rebuild very quickly.
The city, in the next wave, post-fire, I think, took on a really different look and feel.
You know, we had this thriving economy, and we built quickly, and we built up.
Architecture has always been interesting in this city, and there is peer pressure, I think, on Chicagoans to deliver good buildings, innovative buildings. Because the landscape is relatively flat, the architecture had to give the place some interest.
In the late 1800s, Chicago was really thought of as more of a rural backwater, a rough city, an unsafe city, an unsophisticated city. And Chicago wanted to show that it belonged with the other great cities in the United States.
Skyscrapers probably began because architects thought that they could. In cities, it's a place for people to really stretch out their imaginations in every possible way. If you can dream it, you can do it, and it'll happen in an urban environment.
The skyscraper has evolved tremendously, and Chicago has been the home of the skyscraper.
There are a couple things that are important for a skyscraper. One is you have to have steel. It's hard to build a skyscraper out of stone, but with steel beams, you can make a much taller building because the steel is so strong. It doesn't have to be as wide to support as much weight. So with the rise of coal, which gave rise to steel, it gave rise to skyscrapers.
They wanted to build fast, and they wanted to build efficiently. So they developed a new style of building called the commercial style of building. And it's got another name called the Chicago School of Architecture. It's a steel frame, it's clad, in terracotta in many cases, and it's just really simple, fast to produce, fast to construct, cheap, and you get the rents coming in as soon as possible.
You also need electricity to run those buildings because people don't want to walk 30 floors up to their apartment. You need elevators to move people up and down. Those elevators run on electricity. Today, the elevators, they all kind of look the same. They all have the same door, and they're all kind of steel and very utilitarian. But in Chicago in the late 1800s, they were novel. They were beautiful, carved, etched. They were a work of art. People loved to ride in them. And they were put in the center of the building in a very prominent way so people could really see that this building is modern. And some of those old elevators are still in place today. You can still ride them if you want in Chicago.
I would say that every city in America has made an important historical impact on its region. St. Louis, Houston, New Orleans, San Francisco, or Los Angeles. Every city has its own character. And we should also say the same is true for cities abroad. So Shanghai and Beijing are different places. So in every culture, an individual city has an opportunity to build its own brand and have its own character.
Another critical factor that enabled the rise of large cities was the ability to handle and move a lot of water and wastewater. So for a place like Chicago, Paris, or London, building water systems were critical to their growth and success.
At the start of the 19th century, London was a city of about 1 million people. By the 1850s, it had gone up to about 2.5 million.
So for London and other cities in Western Europe, it was relatively straightforward to copy the Roman idea and start importing water into the cities. In fact, they had an advantage that the Romans didn't have. They had the steam engine, and they had pipes where they could pressurize the water and move it around the city.
London's water supply was provided by private companies, just like it is today. And those private companies took their supplies from different parts. Some of them took them from the River Thames directly. The problem with that is that there was no integrated sewer system.
People started using lots of water. And with all that water that they were using, they were creating waste, and that waste had to go somewhere.
The river was low, and the sewers just lay there and rotted. And the stink was so great that even Parliament had to abandon its sitting.
As technology expanded and as populations grew and as we learned more about chemistry and physics and biology, it's the age when we applied science and technology to develop the modern water system that we all depend upon today.
They appointed an engineer called Sir Joseph Bazalgette to create an integrated sewer system. So what Bazalgette did was he developed a system of intercepting sewers. One of them is literally below our feet on the south side, and the other is on the north side. And to do that, he had to embank it. We're walking over one of the main sewers on the north side of the River Thames. This is the great Sir Joseph Bazalgette, CB, Companion of the Bath, a chivalric order. He was the engineer who created the London sewer system. And that London sewer system was put in the late 1850s, 1860s, and it's still running today. He created these embankments that narrowed the river. The great thing about this system is that it took all the sewers from north of the river and it intercepted them and then dragged the sewage down by gravity, and from there it was pumped out. The river began to have a much greater tidal range, and it scoured the river bed, and that helped cleanse it as well. So he did two things. He allowed the river to flow faster, and he also created these fantastic Victorian sewers. This statue of Sir Joseph Bazalgette has got a Latin inscription on top. My Latin isn't great. Flumini vincula posuit. And it means he put the river in chains.
One of the ways that cities improved into the 21st century is public health. The second biggest change is probably energy and electricity, and of course those things are quite necessary for infrastructure to function.
Another very important part of energy is public lighting to improve the safety and security of streets. Imagine a city before you had street lighting. It was a dangerous place to go after dark. Maybe you had a lantern or a candle or a torch. Maybe you didn't know your way around. You would ask a local to be your guide after dark. And sometimes the locals would be working against you and would lead you down a dark alley where their buddies would rob you and beat you up. If you think of serial killers like Jack the Ripper, it'd be hard for them to operate today in a well-lit city. But in the darker London of hundreds of years ago, it was possible for bad people to hide in the shadows of the city to do bad things. It was a dangerous world, these cities after dark.
Indoor lighting had been sought after for millennia. In the ancient world, torches, fire, and candles were often the only options to see after sunset. In rich homes, such as the Palace at Versailles, they used beeswax for candles because it didn't generate as much smoke, but it was very expensive. Oil lamps, sometimes with olive oil from the Mediterranean, or whale oil, were brighter than candles. Whale oil was very popular because it burned brighter and cleaner than wood. However, it also produced a pungent odor. And after the mid-1800s, whale oil became more expensive as whale populations were depleted. But the demand for lighting kept growing, so an alternative was needed to replace whale oil. The introduction of fossil fuels in the 1800s and the invention of newer, better forms of lighting, especially the electric light bulb, changed everything again. Indoor lighting made homes more enjoyable, avoided indoor flames, smoke, and fumes, opened up educational opportunities, and enabled factories to work more shifts. But outdoor lighting is what was desperately needed in cities around the world.
I think people today have very little idea of how dark it really was. It's a big deal now if you have a blackout. The power goes out. Well, the power was always out. It was always a blackout before the 1890s, most places.
Once upon a time, after dark, you really didn't have anything to do but go to bed. Cities everywhere were very dark places. You couldn't really work after about 6.
And so how did people get around? They walked around in the dark. The moonlight was very important to people, and people would arrange their movements sometimes according to whether it was a full moon or not. Who pays attention to that anymore? Well, astronomers, I guess, but nobody else.
Cities saw benefit in the public safety and the personal security of people of having lighting because it made cities safer after dark.
It's much safer for women, it's much safer for poor people. You're much more likely to be able to find your way. There's a very heavy pressure to bring lights to cities.
They also saw economic benefit because then restaurants could be open after dark and stores could be open. You had the whole concept of a nightlife didn't exist before you had public lighting because it wasn't safe. People close up the shop and go home. They didn't want to go out.
Concern about safety at night was an important consideration in the provision of street lighting all around the world.
London in particular built a gas distribution system to build a series of gas lamps, natural gas or town gas they would call it, that would light up the city sidewalks and streets. This street's a typical London street, kind of narrow, a lot of brick. So this is after the big fire in the late 1600s. You can imagine how dark the street would be before there was street lighting and how scary that must have been as well. We're looking here at a gas lamp that was installed in 1910. So it has gas piping through it that goes around to the top. And there are gas bulbs, like these net bulbs, like an old camping lantern or something. And the ladder is here for the lamp lighters, which are professionals who light the lamps. There was a particular person whose job it was to turn the lamps on and off, and that was a lamplighter. Because you did not want the general public to turn these lamps on and off. It was dangerous. If gas would accumulate and then you have a spark, it would cause an explosion. It was not unusual for a gas explosion to happen, killing people or doing a lot of property damage. So this is a dangerous job, but an important job. Now there aren't that many gas lamps left, and not that many lamplighters left either. Eventually, cities like London went from gas lamps to electric lamps, though there are still some gas lamps in London today.
Thomas Edison famously invented the incandescent light bulb in the late 1870s and then commercialized it by the early 1880s. But before that, there were electric lights. There were arc lights. Arc lights are basically a giant spark running between two sticks of carbon. They're extraordinarily bright. They're the sort of thing that are used in searchlights. And you can't make them small. So when arc lights were developed, they were used for street lighting in big cities like London and Paris. But the arc lights are so bright, you put them at street level, they're blinding. So the solution that a number of people hit upon was put them high up on a tower. These kinds of light towers, tower lights with arc lights on the top, were built all over, particularly in the Midwest. And they made a big impression on people. Detroit had an extremely extensive system, hundreds of 150, 160 foot tall towers. So these were built all over the Midwest in the 1880s and 1890s. In 1894, the city of Austin contracted with a firm in Indiana, Fort Wayne Electric, to erect a system in Austin. This is one of Austin's moonlight towers, as they've come to be called. This is the first one that was lit up in 1895. It would have been very bright, and you wouldn't want to look directly at it. The idea was it would spread light over a several block radius. Every place else in the world abandoned their arc light towers by 1910 or so. After the failure of the dam in 1900, Austin was kind of an electrical backwater, was deep and dead, and they couldn't afford to replace their lighting system. They came to be called the moonlight towers because the light that they shed was comparable to a full moon. The way they tested that was the specification was you had to be able to read a newspaper at a distance of 200 yards or something like that. And so the arc light towers, the moonlight towers, stayed around long enough until they were a curiosity and an object of nostalgia. They're not an important part of street lighting anymore. People don't even notice them unless they're looking for them. But when they were put up in the 1890s and probably into the 1920s, they were the main street lighting in the city of Austin. I think having the easy availability of lighting, literally flicking a switch, is an enormous advantage. People have very little idea of how complicated and work-intensive it was just to provide light.
Though street lighting has been around for centuries, it is still an evolving technology. Today, there are nearly 350 million outdoor light poles worldwide. Cities are now replacing traditional light bulbs with newer LED versions that are much more efficient and last much longer. That means they will reduce energy consumption. And these newer lights can have their color tuned more precisely and be pointed downwards to mitigate light pollution.
Cities are responsible for a lot of energy consumption because it's in cities where we have all these buildings that we operate, and those buildings use electricity or natural gas for heating and cooling. It's also a lot more difficult to cool a building than to heat it. We've been heating our buildings or shelters or caves for thousands of years, but air conditioning's only been around for a little over 100 years. And one of the early advocates for air conditioning was the movie theater industry, because they wanted to cool the movie theater to make it comfortable while people escaped the summer sun to come inside and watch a movie in the dark for a few hours. Movie theaters were often the first place people had their exposure to air conditioning, and it helped speed up the adoption of air conditioning across the country.
Prior to the 1940s, building air conditioning was virtually non-existent. And Austin was one of the first cities in Texas to actually have a building with a chilled water system for air conditioning. Well, in Austin, we have extended periods of 90+ degree days. And without some kind of air conditioning system, these buildings are not inhabitable. This is our chiller floor. To the left are 3 5,000-ton water chillers. And over to the right, these chillers make much colder water. They make 19-degree water that we use to create a bathtub full of ice. That's part of our thermal storage system. This system is a chilled water system. What we do is make chilled water around 40 degrees and send it out to our customer buildings. In the customer building, they pass their air over that water and it cools and removes humidity from their air. Technically, we're removing the heat from their air and putting it into our water stream. It comes back, we cool it down and send it back out. This is energy intensive. In fact, for buildings in our region, 40 to 50% of the building's annual electric consumption goes to driving its air conditioning system.
If you look at a city from above, it might look like a living organism. There are resources that come in, food and water and energy, and then wastes that go out. And that flow of inputs and outputs, we call that the urban metabolism.
Without the countryside, there's no food, there's no incoming labor for migration. So urban centers absolutely depend on their surrounding areas. Surrounding areas depend on the city too, because that's the market for their products. So rather than seeing an adversarial relationship between cities and the countryside, what we really should see is that those two worlds are completely integrated.
When you have a city and you have an urban metabolism, you can think about the waste generation as the problem you need to manage. The bigger the city, the more waste you generate, and the more inputs you also need to operate the city. And we can think about efficiency as that measure from inputs to outputs. A more efficient city needs fewer inputs to operate itself and therefore generates fewer outputs as well. So efficiency is a way to reduce the waste stream.
So cities are increasingly important because they're efficient places for the delivery of needed goods and services. Rather than wasteful or using up resources, you can actually use cities as an efficient delivery mechanism for the many, many different things that people need in concentrated spaces.
We have gotten better at our urban metabolism in many places. Buildings are more efficient, cars are more efficient, that kind of thing. However, the cities have also become bigger at the same time. So the total flow has increased in most places. So cities, because they have a concentration of people, also have a concentration of waste.
On December 20th, 2015, a mountain of urban refuse collapsed in Shenzhen, China, killing at least 69 people and destroying dozens of buildings. In some ways, this was an iconic moment in the rapid industrialization of China. One of the most powerful ways to transform an existing city into a sustainable city is to reduce all of the waste streams and then use what remains as a resource. Waste from one process becomes raw material for another. Cities are rife with wasted energy, wasted carbon dioxide, wasted food, wasted water, wasted space, and wasted time. Reducing each waste stream and managing it as a resource rather than a cost can solve multiple problems simultaneously, creating a more sustainable future for billions of people.
A city's problems increase with its size. Far too little chance for fresh air and sunlight. Traffic jams and a general decline in warm, neighborly relationships.
Although more people than ever have moved to cities, the rise of pandemics like COVID-19 seems to beg the question, is living in a city safer or more dangerous? Density in mass transit can ultimately be more energy efficient, but can also hasten the spread of disease. Although energy has brought us modern cities, like everything related to modern energy, there are trade-offs. Since energy is more readily available in cities, access to good healthcare is also available there too. But density, if not handled correctly, can lead to contamination of the environment and rapid spread of disease. As pandemics spread through cities, modern forms of energy also fight diseases. They're used for everything from sterilization of equipment to making the technology, pharmaceuticals, and surgical tools needed to keep people healthy. And of course, electricity, often powered by fossil fuels, is needed to power hospitals.
A difficult, perplexing job faces today's city planners.
There are groups like the Chicago Architecture Center that know the architecture and history of Chicago, but they also study tall buildings everywhere and are considered an authoritative reference for buildings around the world.
You know, Chicago is so proud of our skyscraper heritage and what we do. I absolutely think that skyscrapers owe something to Chicago. And in our skyscraper gallery, we really talk about that.
Oh, wow.
Isn't this cool?
It's even better. Here, look at it.
We were the birthplace, and we're still absolutely pushing out that technology everywhere. You know, there's 4 really definitive things that skyscrapers are about. You know, it's either about structure, and so it's about build. It's about living, and, you know, Marina Towers redefines the way you live in a building. Or it's about work, and in China, CCTV towers redefines the way we talk about work. But here, you know, when we look at what's going on with computer-assisted design, we imagine.
You can have whole new shapes.
We can build very different forms than we used to, thanks to technology.
It doesn't have to be a rectangle that just goes straight up. That's right.
Exactly. When you talk to people like Adrian Smith, who designed the Burj Khalifa, one of the big things on the Burj is talking about the amount of water that they reuse, because there's so much water that you need to, in order to recycle and get into the system. So they're really doing a lot with water innovation too.
And the more we reuse it, maybe the less you have to treat or less you have to raise to the top and that kind of thing.
And so they're using gray water for the, you know, for the toilets. And so just so, and of course, because you're in the desert, you need to think about that.
Some of the important things to think about as you strike out on this mission of energy efficiency. You certainly have to raise awareness of the occupants of the building. And people are far more aware of climate change, of global warming. People want to do the right thing, and they want technology to make it easy for them. In China, for example, you buy your utilities in advance. So you're sort of aware of that you don't want to use that energy and go over your allotment. Also, the hallways of buildings are motion detected. So if there's no one there, the lights in the hallways go off. In the United States, I think that people are interested in buildings that are energy efficient. So just to jump to LED lighting, you have lighting that gives off no heat now. It saves a tremendous amount of energy. These are all things that make it easier to save energy.
We have a new model for a skyscraper gallery, and it's by Woka Architects that are out of Singapore, and it's called the Oasia Hotel. It's a green building on the inside, but it's a green building on the outside. The whole idea is that they're capturing the water, so they have a collective water system, so when water falls, it's reused in the building. It's also capturing the CO2 emissions that come from the atmosphere. So it's really a living, breathing building, both contributing to the structure and the internal workings, but also contributing to the atmosphere. Not something you'd see in Chicago, but certainly something that you can look forward to in Singapore. Singapore, in terms of urban design, is amazing.
Singapore is an interesting case of a 20th century city. In many ways, Singapore is often touted as a hyper-technical kind of city, but in many ways, it's exactly like any other kind of city. It has that architecture, it has that linkage, it has that migration. One of the things about cities that is particularly energizing is that they are never finished. Every city, no matter how built up, is undergoing construction and reconstruction. So if you walk down the street in New York, it's full of scaffolding and they're putting new buildings in. And so everything that's new is kind of ratcheting into something that's already there in this process of evolution.
That is awesome. We don't see that in Texas very often. How many people live in Singapore today?
Today there are approximately about 5.7 million. And out of the 5.7 million, approximately about 3.7 are Singaporeans, 500,000 are permanent residents, and the rest are working in Singapore.
And how many people lived in Singapore when you were born?
Oh, that time there was only about 1.5 million. That's the reason why we have to build upwards, because of the growing population.
Yes, you go overseas to different ways. So you have to go up because the population. What part of town are we entering right now?
We are at Chinatown. On my right is the Muslim mosque. The Hindu temple, this is the first and oldest Hindu temple, Sri Mariam Temple. They are doing a fire walking ceremony.
And they're walking on coals, lava coals. You can actually smell it, like there's incense and things burning, the ash.
It's like a penance,
A penance for your sins, you go walk on the coals. That's amazing.
The Chinese were smart. This was their allocation area and eventually became the financial center of Singapore. So when you bypass here, can you breathe and smell the money?
Oh, you smell the money? Does it grow on the trees? Should we grab some from the trees?
It has a long history, actually. But why you think that it's new is because of the buildings.
Well, some of these buildings are pretty old, right? Some of these smaller buildings are...
This is the original Chinatown building.
Original Chinatown, okay. Yes. Of course, there's new construction next door to the old construction, right?
Yes, and that's for the extension of the subway line.
You were telling me earlier that you're never more than a 5-minute walk away from a train line.
Yes,
is that correct?
That's what we hope to achieve.
I like all the green gardens and things like that you have up high. It's even on here you have flowers and things
correct.
like that.
40% of Singapore has to have greenery. It is like living in paradise.
When you get off the airplane and you head into central Singapore, you are knocked out by the beauty of the roadways. You drive for miles under a canopy of trees creating beautiful shade. It's beautifully landscaped in a climate where you can grow just about anything. Integrating plants and buildings is something that many people have been experimenting with. You see it in tropical climates more because it's easier and they don't have the winter season where a green wall will die. What's interesting about this idea is that all surfaces of a building become participatory in the building. They're either insulating, or they're holding water, or they're creating some kind of habitat, or they're cooling the environment. It's a great technique to deal with heat islands. So greening the walls or roofs of buildings is also part of an efficiency strategy, stronger ecology and better insulation.
Singapore is sort of an irony in that it's both very business-oriented, very capitalistic, but also very centrally planned and coordinated. So they have a variety of boards for housing and public utilities and different decisions that a government might make with its people, kind of like a master plan community you might find in a neighborhood, but instead of it being for a neighborhood, it's for the entire city-state of 5.8 million people. Some of these organizations and planning boards like HDB and URA have a public-facing role, the way to do stakeholder engagement, and they do it through exhibits and places where you can go visit and get some more information.
Urban Redevelopment Authority of Singapore is Singapore's land use planning and conservation agency. The URA develops strategic plans such as the concept plan and the master plan. It allows us to safeguard sufficient land needs for major land uses and infrastructure. This is the central area model. Singapore's land area is just 721 square kilometers. So beyond just being a city, we are also a country. So this means having to support varying needs of the population, ranging from housing, transportation, the economy, industry, parks, recreation. So you get the whole range of it.
When I see Singapore like this, it really makes me understand the density. We really see all these things crammed into one place. I think that's really phenomenal. And I also think, well, what a great planning tool. Every city should make a scale model like this.
Essentially, what we want to do is to create an environment which is very comfortable for everyone to live in, where everyone knows the importance of saving energy, saving water, trying to move around either via walking or cycling, and use more public transport. Whenever we design our flats, we design our towns, we're always planning for the future. The Housing and Development Board is Singapore's public housing authority, where it's actually the public housing provider and town planner. And the public housing actually houses over 80% of the Singapore population. The housing concept in Singapore is a bit different from most other social housing concepts in the world. We actually promote home ownership. That way, they actually have a stake in their country, and then they will also take care of their living environment. Punggol is actually situated in the northeastern tip of Singapore, and it is actually our youngest town, started developing and planning since the early 1990s. As the youngest town itself, we actually had a lot of opportunity to inject new ways of innovations and sustainability into the town itself to make it an eco-town. The first thing is the buildings, the house, the flats itself. Unlike temperate countries like Europe or US, whereby you want the sun because of the cold, in Singapore's context, because of the tropical environment, what we want to do is to limit the amount of heat gain and reduce the cooling need. Most of the houses that we actually built in Punggol, we orientate it in a north-south orientation. That way, it actually allows minimal sunlight to get into the flat. We actually took one step further by mapping in the wind movement to determine how the wind will actually flow into the town through the blocks so that we can actually readjust the block so that more wind can actually pass through. So that you don't even need to on your air conditioning, and then you can actually enjoy the breeze, especially since you're so close to the sea.
There is good transit, there's a good urban planning strategy, there's a great ecological strategy to capture stormwater. As a city-state, they really have their physical planning act together.
This new age builds a better kind of city, close to the soil once more, as molded to our human wants as planes are shaped for speed. New cities take form, green cities. They're built into the countryside. They're ringed with trees and fields and gardens. New cities are not allowed to grow and overcrowd beyond the size that makes them fit for living in. The new city is organized to make cooperation possible between machines and men and nature. Safe streets and quiet neighborhoods are not just matters of good luck. They're built into the pattern and built to stay there. This is no suburb where the lucky people play at living in the country. This kind of city spells cooperation, wherever doing things together means cheapness or efficiency or better living.
Cities are places where many different kinds of energy-intensive activities take place. Now, having said that, we also know that cities are at the forefront of energy innovation. So cities are places where you get that hyper-focused entrepreneurial environment that then touches on energy in this cascading way. Cities are wonderful, but we can make them better. And that's where the smart city idea is quite important.
We hear a lot about smart cities. Nobody seems to quite know what that means.
A smart city is like a giant multi-sided Rubik's Cube where every side is some aspect of something that people need: water, energy, food, transportation, and trying to make all of those parts work together in the best possible way.
We have the opportunity going forward to really focus on putting together the infrastructures to design the city of the future. It's a great opportunity, but it won't happen without an integrated vision and integrative action.
Renewable energy is getting stronger and stronger. Chicago is getting more reliant on wind. I think the wind energy resource will continue to grow. I think coal should be the horse, of the last century that's replaced completely, and we move on to renewable energy.
Cities certainly have always provided an opportunity for energy efficiencies in many ways. And I think that's will be increasingly the case as we go forward, particularly if we continue to develop new transportation modes in cities.
It's not surprising that when we find something that's good, we want to try to make it better. It's a really admirable thing that we're working towards, even if we can't quite decide what it means in any given instance.
You take your choice. Each one is real, each one is possible. Have we vision? Have we courage? Shall we build and rebuild our cities clean again, close to the earth, open to the sky? The choice is yours.
We need to make our cities more efficient, more smart, and more modern. And that will lead to a reduction in the energy resources we need to run the city, and also a reduction in the waste streams you generate, and a higher quality of life. But as we move into the future and become more efficient, we have to make sure we also focus on the human condition. As we build cities around the car, with far-flung suburbs and cars taking up our space instead of people, it's really divided us and separated us.
Cities are offering amazing opportunities now, and you sort of embrace lifelong learning when you're in an urban environment. But I do think cities are still a struggle for families and for children. I think it's difficult to find a high quality of life for children in cities.
The ways that we can make cities more amenable to families is to make it possible for people to live and work and go to school and play in an area that does not require large commute times or large amounts of money to go back and forth.
That means designing pedestrian zones, changing the way cars move about, building protected bike lanes so you can ride your bike to school, building mass transit systems so there's fewer vehicles. Cities can do better by designing around people.
Schools need to be stronger. The family unit, I think, needs to be accepted more in urban environments.
You cannot create your own neighborhood as a family. So this is where thoughtfulness to create environments for people of all ages to thrive, but especially people with young children who have distinct needs for housing and education and recreation.
The advancement of smart cities continues. The smarter our cities, the more we can reduce waste, reuse what's left, reduce traffic congestion, and make buildings more energy efficient. But there are privacy concerns with smart cities. Who controls the data that is gathered on city dwellers? And studies show that more research and development for smart cities has been focused on technology rather than what people need. Done the wrong way, the benefits of a smart city might accrue to those who already have access to advanced technologies, which would only widen the technology gap. This on top of all the other socioeconomic divides. Residents can become smart citizens too, because each individual makes decisions every time he or she buys a product or flips a switch. Access to education and data will be paramount. Connecting those citizens also requires urban landscapes that invite collaboration and neighborly interactions. Parks, playgrounds, open spaces, shared spaces, schools, religious centers, and community centers, all of which played a critical role in the centuries-old design for thriving cities. The more modern and smart our cities get, the more we might need those old-world ideas to keep us together. And we all have a role to play in that story of energy.